I really feel honored to introduce Dr. Karthik Ramani. And if you Google his name, you will see tons of data projects. Actually, one before coming here, he gave me one website, Yang you choose. I have tons of projects. I don't know which you like to hear more about more. So I just read through his design lab, and I counted, was it 50 projects? 50 projects, and each of them was so cool. And then my doctoral student and I had to go study all these individual introductions to select and narrow down to 3 to 4. Can you imagine how hard it was? So it took us several hours.
Oh, thank
anyway, so Dr. Karthik Ramani, you will, I want him to have more time.
Okay, thanks so much. No, actually, Yangi, thanks for inviting me, and did a great job in figuring out what will be most appropriate. So it was easier for me to take that and summarize it. I wanted to sort of give you an introduction to what I do as we go along, but also then get the 3 main ideas that I wanted to bring in. I'm going to be talking more about embodiment. Maybe you could call it embodied learning. But I took that embodied learning part out because I don't think we know much about it now. So I kind of kept embodiment, and a lot of the things that we do are making people, children, students design, build, make, iterate, and so on and so forth. So I'm going to talk about 3 projects, and first one is those of you that came to cyber learning perhaps have seen this robot. We actually had it there. That was a prototype. I will show you more newer versions of it. It's pretty cool. You'll kind of get to see a state of art there. Partly, the second part was a project that I think Yangi picked. The first one is real. It's actually commercial in production, and also it did very well in the Consumer Electronics Show. It won the Best of CES in 2016. So this is real. This stuff, research prototype. Okay, so I'll kind of like talk a little bit about this, but very different from this architecture, but has substantial implications in terms of how learning can happen in 3D space rather than on a computer with a keyboard and so on and so forth. So I'll sort of talk about it, but also talk about tools in space that augment the robot itself. Okay. And the third project is sort of, I think you picked this rightly again, with all this data that we are getting, like gestures, voice, content, and so on and so forth. We are seeing a lot of efforts, including earlier talks, where you are looking at representing knowledge and content and concept, how these constructs change in people's minds. So you have to analyze it. So we do have a bunch of projects done by our students where you can look at large gestural data, but also have human intelligence in terms of what you want to look at. And analyze it. So I'm going to talk about that. But just to give you a feel for, you saw a lot of projects, but there are only 3 big things in our lab. The first piece is more in the geometric learning of hands and shapes and so on, a lot of the CNNs and so on and so forth. A lot of this work is in computer vision area. So I'm not going to talk about that. The second group is sort of more on wearables, tangibles, making robots and things. That is something I'm going to talk about, but we also build tools for design of these things. Most important, I guess, is this is sort of like a result of these 2 areas, and I've been, you'll get the context of why design, build, play, toys, and STEM learning for children. I kind of think I've been doing this for a long time, but without knowledge of the educational community or learning science, which I got exposed to maybe about 7-8 years ago. I've been doing this for a long time myself. I said, oh, there's a whole community interested in it, and actually got introduced to this area by Janet Kolodner and a few other friends. So they are my mentors. I'm looking for more people to learn from. So I'll talk a little bit about that. Okay, at the center of all this is the human idea, right? Human, children, whatever. So so a lot of our lab team is trying to take complex technology and making it easy and accessible for people to use. That's sort of like the driving motivation, but also we have depth in a couple of areas which are related to these that we bring into this space. And then taking our research, the best way to sort of test it out this with kids because they'll tell you it's working or not working. You really don't have to go any other place. I've been teaching a toy design class. Actually started this in 1991 or 2, right after I graduated the centennial year of Stanford. So those days, nobody cared too much about it, but the last 8-9 years, you know, the maker spaces, all this is a hot stuff. So it's sort of like they built a big museum. So if you ever visit Purdue, you can see our toy museum. There are like maybe 800 or 900 toys. They don't all work, but you can come and see them. So we have been doing this for a long time. A lot of these are more electromechanical with sensors. The technology changed with time and so on. A lot of it was inspired by one of our alumni who started a company for design software called Parametric Technology Corporation, Pro Engineer. It's a very well-known tool in design. The chair position I hold is actually endowed by him, and sort of he was my inspiration from the beginning. Sort of moving phase, why all this is kind of like catching on and robots, and now we want to do a lot of other things with robots, sort of because of multiple things going on in the last, I would say all this makers, the last 7 to 8 or maybe 10 years progressively, is all these electronics like Arduino and so on becoming much more easier to use. Programming languages, not just this, but things like Scratch is so popular now, Blockly by Google, and then 3D printing and all this. And robotics is just a combination of all these areas: controls, electronics, materials, all the soft robots coming now. Now more and more computer vision and AI and so on and so forth. So it's kind of like easy to do. But yet, all these are coming together. Yet it's very hard for, what inspired me was a lot of people visiting my toy class used to say, hey, you've been designing toys and doing all this stuff, and I had done 2 startups earlier, one on visual search in the 2000 and so on. I said, oh, you're, and I used to tell them all the time, really hard to get your toy out because there were all these big Mattels and Hasbros. In fact, one of my students was a VP at Mattel. It's hard to get into the real world with your research. But all that changed with this crowdsourcing and all coming in. And we said, well, this is time to try something out. And we had a project, but what you're going to see is the output of the project. But what really happened before this is that we were researching, and I'll tell you a little bit of the story after you see this video. But this is our the robot that went into Consumer Electronics Show.
Robots.
Oh.
But building your own robot can be overwhelming and unintuitive. Not anymore. These are the guys from Zero UI. Their dream is to make robotics easy and fun for everyone. Their team created the Zyro, the world's first hand gesture controlled robotics kit for everyone. Zyro consists of 3 parts: the motorized modules, the smart glove, and the smartphone app. Zyro's modular design enables free-form robotics construction, enabling you to build virtually anything. Modules can be animated in a hinge or 360-degree rotational movement. Pair your glove to the modules with the smartphone app and bring your robot to life. Whether you're a robotics enthusiast, an aspiring superhero, evil genius in training, or someone looking to expand their creativity, Zyro is for you. Zyro is for all ages and all genders. There's no limitations. You can design and build it from scratch or use a pre-made starter kit. Design, build, rebuild. Zyro can be used over and over again, making new and different robots each time with the same modules. Zyro, let your imagination come to life.
Okay, so they had a very successful CES and were named, best of CES finalists. So after that, it was good to be on the news. I was personally on a lot of media because the CEO was not well during that show, but also we were named as one of Lego's worst nightmare. For one thing, you don't need all those plastic blocks. They're not good. They make 49 billion blocks a year. Not that Lego is not good, but sort of building on. This is actually a real picture, not made out. Once people see this humanoid kind of things. I kind of heard Cliff Nass being named earlier, but basically they get curious. They get interested, and then they want to do the next thing. And then they start potentially wanting to change this and that. They can change the design. Currently, the robot is actually integrated fully with Blockly and also with Amazon's Echo. So you actually talk to the robot, and its skill sets you can make it do things that you want. So it's kind of advanced substantially. In fact, this CES, they demonstrated both those factors. But kind of moving ahead, in our lab, we have sort of used this kind of thinking of taking our research and running workshops. We run workshops in the summer for about 32 children for 10 days. And this is fully instrumented makerspace. It's sort of like a makerspace for kids, if you may. And we have cameras, and we record all of this. And I've been working with some colleagues in education to sort of analyze and look at what's going on, and analyzing the conversations and seeing whether their language changes during those days. And of course, using the design framework, I'm an engineer, sort of understand this design-based research idea. So sort of using that as a means for iterating and improving these ideas. So this is kind of going on now. I mean, like, this is sort of what we want to do as we move forward, at least from our perspective, is looking at this whole framework of design, build, make, and so on and so forth, and then bringing in a better and more deeper understanding of embodied learning. So that's kind of in our wish list. So sort of moving on these directions, the idea of like natural interactions is important in robotics, and HCI, a lot of these areas and researchers are studying these areas, but I'm particularly interested in hand-driven input and sensing techniques for these multimodal type interfaces, and primarily because you can do a lot more. It's much richer. You can get a lot more from it, and also that's the way that we live and work with. We don't want to constrain humans from communicating in their more natural modalities, but also allows access to people in terms of controlling these robots. When if you put this glove on the hands of a kid, they kind of understand very intuitively what to do with their hands. You don't have to focus on a controller for one. And also the mappings, you can create custom mappings. And the glove, for instance, understands about 10 to 12 very natural gestures in terms of movements, like for moving forward and backwards, almost like a car's acceleration pedal. So it's intuitive to learn that. I'll kind of move on from that to a more mixed reality kit. This one is a lab prototype, so it's sort of like more DIY robotics, but this is kind of the workflow here. So you sort of have a lot of these modules, you assemble it, and once you assemble it, the head-mounted vision system, in this case the HoloLens, becomes aware of what's going on. So it sort of builds a virtual model simultaneously. So some of the parts can be real, some of it can be virtual, but you can also start simulating and potentially like combining real and virtual pieces together in this kind of a robotic form. It's kind of like a DIY robot, and you can kind of see that you can use even voice commands to group a bunch of interactions and actions and sequence them, change the sequence. So sort of programming and reprogramming it is very easy and literally done with the hands. And you can build like a storyboard with it and change those sequences. I'll kind of show you a little bit of our MR kit here.
We present Anibot, a mixed reality modular robotic system. Anibot construction kit consists of sensing modules, structure modules, action modules, and base. Once assembled, users can put on the AR headset to start a mixed reality interaction.
So a lot of these are virtual instruments, for instance, here.
Users can create their own DIY robot with the system's construction kit. They can also follow the virtual guidance to assemble an existing design or suggested.
This I think is very useful for education because you can bring in AI and other things into this mixed environment.
Activate the tweaking mode and perform virtual tryout in order to find a working solution. The sensing modules allow users to program logic events. In this case, the cover will drop when the water is enough. Taking advantage of mixed reality, users can set virtual keyframes and create robot animations to interact with the environment. Each animation can be saved into an action sphere. By combining them together, users can create even more complex animation. Now we demonstrate a
Okay, anyway, you get the idea. It's sort of like
a mixed reality
mixing
robotic system.
physical and real.
Construction kit consists of sensing modules.
Okay, so so kind of like taking on to the third piece, I kind of talked a little bit about something that's real, tested, and we're building on. Second piece was more a research platform, and of course it's hard to put that, doesn't work as well as the video is showing you. Gestures are much more harder to make work with, but if you kind of look at it, it illustrates a lot of ideas in terms of where that kind of technology can go into, and as I was suggesting in the MR way, you can bring and teach physics, and you can teach electronic kit building. You can teach a lot of things, but the technology for that is more or less there for developing educational tools on top of it. The last part is more to do with, okay, we got all this data, so what does it mean, right? So we think that there's a compelling need for putting tools in the hands of educators that can impose their idea, saying that I'm interested in these types of actions, or I'm interested when kids touch this, how many times did they pick this up? And if you want to look at all those questions and do analytics, it's very hard to do. So we have been sort of looking at developing visual analytics tools with one of my colleagues in Maryland now, Nicholas. He's a visual analytics guy. So we have developed a bunch of tools that can allow you to do gesture analysis over gesture data. For instance, here you're sort of seeing some classified data in terms of results, or if you want to get into details of how the angles and the temporal elements change, you can look at it. Furthermore, as I was suggesting earlier, you can cluster the data, and we call these postlets. So we developed a number of artifacts and ideas that will sort of illustrate how the various modalities of interaction work here. For instance, how many times did the user go from here and end up in this gesture? So the thickness of these lines and so on and so forth illustrate the number of, the density of these types of interactions. So it's very useful for people to look at and abstract out and figure out and impose their ideas onto it. They can look at what they want, right? So the HCI idea is sort of applied to the tools in this case in terms of how you can do gesture analysis. So if you want further details on this, this was one of our publications in TVCG and so on last year. Okay, so sort of moving on here, the idea of, like I was trying to talk about, this idea of post-state and using some ideas in graph analysis and so on. We developed a tool for further looking at these, clustering the data and doing analysis on it. So it kind of gives you a rough feel for the nature of these tools and so on and so forth. Again, this is a research project. It's sort of, I would say, advanced prototype. We're trying to use these for our own work. First, we become our own users and further develop these types of ideas. I kind of wanted to end here in terms of suggesting that we can build a lot of tools, and I like this because we are tool builders, and we like to make them real, of course, but of course bringing in more educational constructs and ideas of learning science into these environments will help us build better things for having educational impact. Sort of ending, I wanted to end with the same thing that we started with. And certainly now, I think with all this vision and AI, we are getting closer to being able to understand the human better. We're still a far distance. And in my opinion, a lot of the current research that is going on, but also a lot of the commercial tools that we have built and put it out in the market, maybe some of them are a little ahead of time, right? So I think this is the idea of creative ideas coming out, and or we'll be iterating in the real world as well. It's not that all these become real immediately. So my conclusions, just to sort of set it up for this workshop, idea of like engaging and flexible platform that can afford all these various things. These were our design goals, sort of like tinkerability, give children an environment where they can make mistakes, learn by iteration, and things don't work well, that's fine, and this idea of exploring the design space there and using that to learn concepts in physics, engineering design, etc., right? And the importance of embodied interaction and all of that. And also this idea of multimodal sensing, I showed you a little bit of that as an example in terms of us going further, potentially. If I had Aaron's work available and put it into our robot with vision, it would probably be doing more interesting things. But also some of these, the last statement, I think Cynthia made a comment along. So we have also been thinking along these directions that robot is a partner that can be educated by you, and grow up with you. So sort of learning along and helping us do things in the physical world. So with all that, just wanted to acknowledge all the students that did all this great work that I'm presenting here, and also acknowledging NSF for past support and continued support in these directions.